In this video, I'm going to explain vertex form and graphing transformations, and I think this is one of the most important ideas in high school math. So at the beginning, let's start with some vocabulary. Y equals x squared is called a quadratic equation or quadratic function. The graph of y equals x squared, the graph of this, makes a shape called a parabola. And this function, y equals x squared, is called a parent function or a mother function. And for all quadratic functions, the parent function is y equals x squared. It's known as the parent function because it's the most simple quadratic possible, and all other ones are derived from it. They're offspring. Perhaps the most important point on a parabola is this point, the vertex at 0, 0. Okay, let's look at some offspring. There are three types of offspring equations, two that involve shifting and one that involves stretching. So the first one here. What if we take this y equals x squared and we add a value of k to it? And let's start with the k value of -5. What's going to happen? Well, there goes our parent function, and look where it is now. It's vertex down here at 0, -5. If I press play, notice as k gets smaller, the vertex and the entire parabola shifts down. As k gets bigger, the parabola shifts up. Okay, so that's how we shift a parabola vertically. How do we shift a parabola horizontally? Well, instead of this one where we were adding a value of k, here we're adding a value of h, but what's the difference? Well, in this one, the k is added after the squaring. The order of operations is going to do the exponent first, then the adding. Whereas here, the adding comes first because it's in a grouping symbol before the squaring. So what do you think is going to happen to the parabola when the slider is pulled to the right, to values like 10? What's going to happen to this? What happens if h is, let's say, 4.3? Where's the graph going to go? Well, let's see. Here's the function when h is equal to 0. As I shift it to the right, what? It goes to the left. That's so weird. Why did that happen? Well, here's why it happened. Let's put it back at 0, 0. Okay, so when let's look at the vertex. For the parent function, the vertex is at 0, 0. In other words, an input of 0 for x leads to an output of 0 for y. Up here, when we plug in 0 for x, 0 squared is 0. So an input of 0 for x leads to an output of 0 for y. For the function here, though, when this h is a 4, let's actually make it a 4. In order to get an output of 0 for y, the input for x has to be -4. In order to get a 0 to come out, the only way to get a 0 to come out is for this to be -4, because -4 plus 4 is 0 squared, which is 0. So the only possible way to get 0 coming out, this y value of 0, the only way possible to get a 0 for y is if the x is the opposite of this. So that's why it moves opposite of the way we would expect. And when I press play, notice as the value of h gets bigger, as it's getting bigger, the parabola is shifting to the left. Shifting to the left. So h moves the parabola horizontally, but opposite of how we might expect. In the general form that you're going to see later on, there's a minus. And that's kind of odd. Normally, general forms have pluses in them. Okay, so we know that adding or subtracting numbers to an x squared will shift a parabola. But what happens if there's multiplication instead? what happens? Well, I'll tell you this. It don't give a shift. Instead, oops, let me turn off this one. There we go. Instead, what's going to happen is it don't give a shift, it gives a stretch. That is called a stretch. How would you describe what's happening as the value of A gets bigger? Many students say one thing, and I'm going to talk about later why I don't like the way that most students think about it. What happens if the value of A is less than 1? As you can see, I'm going from 1 to 10 right here. But let's make that a 1, and let's make this a 1/100th. What's going to happen if A is less than 1? If I pull this to the left, that's right, it's going down. So it goes up, and then the value of A is getting down. We'll call this the stretch factor. So if the stretch factor is 0.48, this is what happens. All right, next question. What happens if A is negative? What happens if I make this 10 and let's say negative 10? What happens if A is less than 1? Watch what happens if it goes down to the negatives. Whoop. Okay. So we call this inverting. When A is negative, the parabola is said to be inverted. You could also say that it has negative concavity, or it's concave down. And if A is positive, it's concave up. So concave down, concave up. Inverted, and I like to call this verted, but that's not a word, so it's just kind of fun to be ridiculous like that. Okay, now what most students would say is that the parabola gets thinner as A increases. So they'd say right here, it's getting thinner, 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 skinnier, skinnier, skinnier. However, that's not what's really happening, and I'd like to explain this. Here is the table of values for the parent function, y equals x squared. So we take these values and we square them. Negative 2 squared is 4. 0 squared is 0. So that's the parent function. But look what happens if we make a equal to, let's say, 10. Let's say we have 10x squared. Well, then this negative 3 squared becoming 9, it'd be 9 times 10, which is 90. So here are the same points. So this point right here, 1, 1, became 110. This point here, 2, 4, became 2, 40. So everything is 10 times bigger. So it didn't get thinner, it got taller. In much the same way that when I was in 8th grade, I was the shortest kid in 8th grade, grew 5 inches my freshman year, many more my sophomore year, and people thought I got skinnier. It's not that I got skinnier, it's that I got taller and I look skinnier. Okay, wrapping it up. When you have these three things together, it's called vertex form. The three letters A, H, and K that are used to transform the function are called parameters. X and Y are the variables. The other letters are called parameters. Each parameter affects a different aspect of the transformation. When the three parameters are put together in one equation, it's called vertex form. So this quadratic is in vertex form. There we go. All quadratic equations can be put into vertex form. Each parameter controls a different thing. K, this constant added at the end, shifts a parabola up or down, so it shifts it vertically. H shifts horizontally, but just opposite the way we think. That's why there's a minus here. It's a minus. So when we subtract 10, x minus 10 shifts it over to positive 10. Minus 10 shifts it to positive 10. And then, so k shifts vertically, h shifts horizontally. And what does a do? A affects two things. It affects the vertical stretch factor. When it's bigger, the parabola is going up faster. And so it affects the vertical stretch factor. And then if it's negative, it actually affects the concavity. So A affects both the concavity and the stretch factor. Okay, now what I've got hidden in this folder is a mystery parabola. There it is. Okay, and what I'm going to try to do is do some curve fitting so that I can get this red one to overlap with the purple one. Let me zoom in a lot real quick. I'm going to try to get the vertex of the red to match up with the vertex of the purple. So the first thing I'm going to do is shift it down. Okay, and then I'm going to shift it horizontally over. I think I need to zoom in because that does not look right. There we go, that looks pretty good. And now I want to change the concavity. It's going to be negative because it's concave down. And there we go. And notice when I turn the mystery parabola off, it matches up with what I've got. Here was the mystery parabola. Notice this is in standard form. This is in vertex form. Standard form is y equals ax squared plus bx plus c. Notice it shares the same a value, an a value of -2, but b and c and h and k are different. So any parabola in standard form can be rewritten in vertex form and match up. To end things, I would love to do this. My students love it when let me zoom out, have the A, H, and K sliders all going at the same time. Let's slow this one down and make this flapping around. Let's make it go faster. Doesn't that look awesome?